Hey everybody, today we're going to take a look at 10.1e. This is just one particular example that we're going to look at. We'll look at a couple more before we're done here. By the time everything's said and done and we're done with this particular section. This section deals with testing two population means from two independent samples when we do not know the population standard deviation for either sample. Okay. Now, knowing or not knowing the population standard deviation determines what kind of test statistic we're going to use. We're going to use a t-distribution because we do not know the population standard deviation. So let's take a look at an example, and let's take a look at some of the process we're going to go through, along with some of the ideas on using this. Let me do a screen share here. You should have gotten this a couple days ago. Okay. And this is section 10.1e. We'll go over the other section on two proportions a bit later as well. So we'll be using 10.1e, the two sample t-test. What changes here is we have two samples. They're both from independent populations. In other words, you can't be from each population at the same time. The formulations for H0 and HA reflect the following. We could have mu1 equals mu2 for H0, which means mu1 does not equal mu2 for HA. We could have mu1 is less than or equal to mu2, which means mu1 is greater than mu2 for HA. Or we could have an H0, mu1 is greater than or equal to mu2, which means mu1 is less than mu2 in HA. So to use the t-distribution, we're going to take a look at the degree of freedom. Okay, the degree of freedom changes a little bit here. We're also going to look at the variances, whether or not the population variances are equal or not equal, as I stated. If we assume the population variances are equal, we pool them. If they're not equal, we do not pool them. So what in the world does that mean? Well, when you look at the test statistic formula that's in the instruction part of the Alton-Newton program, you'll see that they have two sets of test statistics. One of them, if you look at it, the denominator is really what changes. And in one of them, if you look carefully, one of them in the denominator, the numerator that has the variances, the sample variances, are in one numerator. That means they're pooled. When you look at the other one, where you have one variance in one fraction plus another variance in another fraction, that means they're not pooled. Now, this changes the value of the test statistic. Sometimes it changes it a great deal. Sometimes it doesn't change it all that much at all. It just depends. But to properly use the test, we have to assume the variances from the population for both cases are either equal or they're not equal. Now, we have hypothesis tests to show that. We're not going to go through those hypothesis tests at this point. So let's take a look. Let's move on here. So we're going to use the p-value and not the critical value, okay, like we did before. Okay. So let's take a look at how we can do this. Now, if I look at the hypothesis, H0, I have a 1 and a 2 next to the mu's. And in fact, in HA, I do too. Now, what that does, that just distinguishes the two groups. We have a group 1 or a population 1 and a population 2. How do we determine which one's a population 1 and which one's a population 2? Well, actually, it doesn't matter when we do the tests, as long as we're consistent. But there are some kind of rules of thumb. Once in a while, we have the data already summarized like we do here. So it's clear that in this case, whatever this is about, they want Burgerstop to be group 1. Whatever this is about, they want Fry World to be group 2. Other times in the problem, it'll state something like, the county of Ada has a mean income that is greater than the county of Bay County. So typically in that claim, sorry, dog, just heard another dog outside. Typically in that claim, we take group 1 to be the group that's stated first in the claim and group 2 to be the other group. Okay? So that's kind of the rule of thumb we're going to follow. So if I look at this, oops, let me go back up here. So if I look at this, again, we have BurgerStop as group 1 and FryWorld as group 2. Okay. This data, sometimes it's in the margin of a problem, sometimes it's right out here like I have here. BurgerStop is mentioned first in the claim, and it is population 1. And I'm going to mention FryWorld second in the claim because here's the claim. The claim that the mean amount spent by customers at BurgerStop is greater than the mean amount spent at FryWorld. Okay. So I'm going to look at that, and I'm going to perform the hypothesis test. So this hypothesis test requires the same 6 steps. The only difference is how we calculate that test statistic, because we have 2 populations, and also the symbols in the null and alternative hypothesis, and that we have the mu1 and mu2. So since the claim is that BurgerStop, which is group 1, has a greater mean transaction than group 2, which is FryWorld, that's HA, because it doesn't have an equal. H0, BurgerStop then would have to be the opposite of that, so that means it's equal or less than the mean transactions from group 2, FryWorld. Okay. Level of significance is 0.05. When I use the 2-sample t-test, which I see here under tests, number 4, I have it pictured out here. I select that. I get a test statistic of 1.45 and a p-value of 0.0762. 0.0762 is greater than 0.05. So based on this data, we cannot support the claim that the mean customer transaction at BurgerStop is greater than the mean customer transaction at FryWorld. Why? Well, because remember, HA was the claim. We failed to reject H0, the opposite of that claim. So that means we can't support the claim. If I look at the input, since everything is summarized, I have mu1 is 5.46, standard deviation for the sample is 0.89, sample size for group 1 is 22, for group 2 it's 5.12, standard deviation is 0.79, the sample size is 30. I highlight, just like before, the symbol in the alternative hypothesis, which is a greater than. Do I pool? In this case, let's go back up. If we assume the standard deviations or variances for the population are equal, we pool. Okay? And we're going to assume that according to the problem. Since that's the case, we highlight, we highlight yes, press enter, we get this. So there's our test statistic, 1.45. There is our p-value. Our degree of freedom, we'll talk about that in a minute. And it just reiterates x bar 1, x bar 2, standard deviation 1, and standard deviation 2. Our degree of freedom here was 50. Let's go back up to our summary. Our summary table had a total of N2 and N1 would be 52 if I add those together. If I subtract 2 from each, or if I subtract 2 rather from that sum, I get 50. So now, the degree of freedom when we pool, when we assume the variances are equal, is the sample size of 1 plus the sample size of the other minus 2. If we assume they are not equal, if we assume that the variances are not equal, and we do not pool, then we choose whichever is smaller, N1 minus 1 or N2 minus 1. Okay? Hopefully this helps you out in your journey with respect to doing these problems. Again, if you have any questions, I'm always available during the morning hours and most days in the afternoon. Just give me an email. If you still are struggling with this, then give me a holler and we'll do a Zoom session. Have a good day.